back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries that are revolutionizing our world and touching our lives. And today we have a special guest all the way from the Adler Planetarium in Chicago. She's Dr. Lucienne Walkowitz, and we're going to be talking about Mars. You know, the National Geographic had a very spectacular season 1, a program about Mars, interweaving fiction with fact. And in the second season, airing very soon on the National Geographic Channel, we have season 2, again, continuing a discussion of what it's like to actually live on Mars. And Lucienne, myself, and many other scientists are featured on this National Geographic program, Season 2. Well, with us today to talk about going to the stars, and specifically going to Mars, is Dr. Lucienne Walkowitz. She got her bachelor's degree from Johns Hopkins University in physics. She has a master's and PhD from the University of Washington. She's taught at Berkeley and Princeton. And now she's an astronomer at the Adler Planetarium in Chicago. So the next time you may be in Chicago, why don't you drop by the Adler Planetarium? It's one of the great tourist attractions in the great city of Chicago. So, Lucienne, glad you could be on Science Fantastic.
Oh, thank you so much for having me. It's a real pleasure.
Okay, well, the first question for you is, think back now as when you were a child. When you were a youth, what steered you in the direction of science and then astronomy?
You know, in terms of what steered me towards astronomy, I actually got my start right down the hall from you in the City College of New York. But long before that, I was always just a really curious kid. You know, I remember distinctly like hiding a loaf of bread under the couch when I was little just to like see what would happen. So I was always doing things to try and look at the natural world around me. But when I was at the end of high school, the New York Academy of Sciences had a summer research program for high school students. And so I actually worked with your colleague, Miriam Sarachik, in a solid-state physics lab. So in other words, studying all the little silicon semiconductors that make up all the cell phones and wonderful technology that we have today. So I discovered my love of research right down the hall. And, you know, after that, it was really a matter of trying to combine all of the different sciences that I really liked. I liked physics, but I also liked chemistry, and someone suggested to me from the New York Academy that I might really like astronomy because it's so multidisciplinary. It weaves together chemistry and physics and now even biology as well. So it really was kind of the perfect thing for me.
Okay, now, when you were a youth, did other kids, your peers, begin to think of you as a little bit strange? I mean, I remember when I was a kid, and I told my friends I wanted to become a physicist. They said, what? So when you were a kid, did you also get some of these strange stares when they found out you were going to become an astronomer?
Well, you know, when I was really young, I don't think that I knew that I wanted to be an astronomer. For a while, I wanted to be a marine biologist, and, you know, I wanted to be a comic book artist, too. I have a long-standing interest in the arts. So, you know, I think I'm just kind of interested in the world. So definitely, I never told anybody about, like, hiding that loaf of bread under the couch, which I think definitely would have gotten me, like, some weird looks. But, you know, I think people thought I was quirky but just curious.
Okay, let's get right to it now. National Geographic Channel is entering Season 2 of their award-winning docudrama called Mars. Season 1, they had actors and actresses portray astronauts, and also they interwove interviews with scientists, and you appear in Season 2. So first of all, let's talk about Mars, traveling to Mars. To go to the moon, well, it's a snap. 3 days and you're on the moon from Cape Canaveral to the moon. But to go to Mars, how long does it take to go to Mars, and what are some of the problems that astronauts might face?
Well, with our existing technology, one of the most optimistic outlook on going to Mars would take you about 6 months. So it's a pretty long trip. And, I think always you mentioned the moon. Here at the Adler, we have one of the Gemini capsules from the early moon missions, which is, like riding in a very, very small compact car, maybe not even that big. And so 3 days, with somebody in a very small space where you really can't get away. I often look at that capsule and think about the psychological challenges of just being away from the Earth and with other people for a long period of time. But when we talk about going to Mars, and particularly any kind of long space travel that takes longer than, a couple of days, there are a lot of physical hazards that we have to think about. So the big one is always this cosmic radiation. We have cosmic rays that come into the solar system from the rest of the universe, and those can create really difficult problems for human biology. We all know that radiation's not good for you here on Earth. That's why we get those lead blankets put over us when we get an X-ray and stuff like that. But being out in space, we really don't have great ways of studying what happens to the human body out in space that long. And I think it's a really interesting thing about human spaceflight is that every single mission, whether we want to send, people to Mars to either, go in orbit and come back or maybe to set up camp there, there's really no way to meet the health standards that we hold for astronauts that, for example, live aboard the International Space Station, because we haven't done the experiment yet. And so, it's a really hard thing to study without actually just doing it. But we do see that things happen to astronauts' bodies. For example, changes in eyesight, changes in bone density. So almost every astronaut comes back with osteoporosis, which then gets better over time. But the changes to the human eye seem not to reverse themselves with time, and they're not fully understood. So it's a really challenging place, both from a physical standpoint, but also from a psychological standpoint as well.
Now, the world's record for being in outer space under weightless conditions is a little over a year, but you're talking about a mission that may take about 2 years. And so that means, of course, that our astronauts are going to have to be trained to live under low G. And you mentioned the problems of bone density and things like that. Do we know what happens to the human body if we're under weightlessness or low G conditions for 2 years?
Well, not for 2 years. We do have this wonderful example of the Kelly twins who, very unambitious family, of course. Both of them are astronauts, and they're twins, of course. So, just recently, one of them spent a year up on the International Space Station, whereas the other one lived on Earth. And in the very near term, we're going to see a report from NASA on all of the changes in their genes. So it's very unusual to have the opportunity to study two people, one in microgravity and then one here on regular old Earth gravity, who have exactly the same genetics. Okay, listen, we're going to have to take a short commercial break, but after the break, we're going to get right back to Mars, the National Geographic Special entering Season 2. Don't miss it. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking to Dr. Lucianne Walkowicz, who appears in a new National Geographic docudrama, Season 2 of the program called Mars. And yes, we are talking about going to the Red Planet. The President of the United States has made it official. Last November, the President said that, we're going to go back to the moon. In fact, starting next year, in the end of next year, the SLS booster rocket is going to take a trial run around the moon. We're going back to the moon, and then after that, to Mars, and then beyond. To the asteroids, maybe Titan, who knows, and maybe to the stars. Well, with us today is Dr. Lucianne Walkowicz, who's going to walk us through the steps of what it would be like to be on Mars, and then one day, our descendants may one day visit the stars. She's an astronomer at the Adler Planetarium. She got her bachelor's from Johns Hopkins University in physics and a PhD from the University of Washington. She's also studied at Berkeley
and at Princeton, and now she'll be on the National Geographic docudrama. Well, Lucianne, where we last left off, we were talking about going to Mars, and let's say now we are on the red planet. What is it like? What's the weather like on Mars? What would it be like to roam across the surface of the red planet?
Well, I think it's a funny thing about living on Mars that the weather is whatever you make it. So Mars, of course, has its own weather. It's known, of course, for these very high winds and these huge global dust storms that cover the planet, most notably earlier this year, blotting out the Opportunity rover from view. So we have a fair amount of data from our spacecraft on what the weather is like on Mars. But for human beings, Mars is not a very hospitable environment for us. So if we were going to live there or walk around on the surface, we'd have to live in some kind of habitat. And that might mean, building domes on the surface. It might mean actually building habitats under the surface into existing lava tubes. And we would be able to tune the environment to be really whatever we wanted. So that means that you'd have your perfect climate-controlled environment, ideally anyway. But if you wanted to go for a walk, you would definitely have to have the protection of a spacesuit. So, again, probably better than being exposed to the elements on Mars. But also, I think as Earthlings, we get used to certain things like having the experience of a breeze or the feeling of sunshine on our face. So while it would be a fantastic experience from the standpoint of, you'd be walking around on an alien world, and then when you were home, you'd have whatever your perfect climate control is, you'd also miss out on that experience of just being out in the wilderness. So it would be definitely pretty different, I think, for human beings who are so used to experiencing their environment in these subtle ways.
Okay, well, Elon Musk, the billionaire, has ambitious plans to eventually put up to 1 million, get this, 1 million colonists on the red planet, starting by gradually melting the polar ice caps. So once again, Mars would have water, liquid water, freely flowing through the ancient riverbeds that dried up about 3 billion years ago. So, what are your thoughts? Do you think it's possible that one day we might be able to tamper with the atmosphere of Mars, given the fact that it is so cold there, but given the fact that to live on Mars, we may eventually have to terraform Mars, like we're terraforming the Earth right now. But what are your thoughts?
Well, I think it's really challenging. So I am very motivated by finding out whether life existed on any of the other bodies in the solar system. And Mars, for many reasons, first and foremost, that it's just really close by in astronomical terms, and it's fairly easy to land on. It doesn't have this, very thick, hot, choking atmosphere the way that Venus does. It presents a really amazing environment to figure out whether life originated on another planet besides Earth or whether that life is similar. And if it didn't ever get started there, then why not? Mars has a lot to teach us. And the thing about terraforming is that it really transforms the entire environment, and that means that you lose the opportunity to answer some of those questions. I also think it's really challenging from just a technical standpoint. So let's say you could melt all of, those polar ice caps and get all of that carbon dioxide into the air where you can make the atmosphere thicker. Well, you might be able to have liquid water on the surface. The ability to have like a lake or an ocean comes down to both temperature and also pressure. So, you would be able to have liquid water on the surface, but the thing is that your atmosphere would still be super dry. So even though the water didn't boil off immediately like it would, if you were to go to Mars right now and pour a cup of water, the water would boil off and it would be gone immediately. But even if you had a warmer atmosphere and more pressure, the water would still evaporate into the atmosphere, and so you would lose it pretty quickly. So I think that, one of the things that both the Earth and Mars teaches us is that planets are really complicated. And, we don't really have a great way of controlling the changes that we're making to the Earth's environment that are making it less hospitable for us, as you pointed out. So, I think if people want to transform the Martian environment, we should think really carefully about the things that we might give up about learning about life in the universe.
And speaking about life in the universe, first of all, have we found any evidence at all, even the slightest microscopic evidence of life on Mars? And then recently, it was announced that there is a lake, an underground lake of liquid water underneath some of the polar ice caps. That's stunning news, liquid water under the surface of Mars. But, well, what are your thoughts about these recent discoveries?
The lake is so exciting. So to answer your first question, unfortunately, we don't have any evidence yet that there's been life on Mars. I think sometimes people think that it's like a conspiracy or something like that. But let me tell you, myself and my colleagues, if there was life on Mars, we would be shouting it from the rooftops. It would be one of the most transformative and amazing discoveries for us to ever make, whether it was past life or whether it could even be life under the surface today. So all we can say right now is that we don't see life on the surface, but it doesn't mean that there isn't life there somewhere. We have to, literally do a little more digging. Now, as far as that underground lake, I think that is such a cool discovery, in part because it is made with very similar technology that we use to study lakes that are under the ice in the Arctic here on Earth. So there are a bunch of different projects done by people who are interested in going to places like Europa, this icy moon of Jupiter, that look for deposits of water underground and under ice layers. And so the fact that one of these underground reservoirs exists on Mars, we don't know whether it's salty. We're not really super sure how much water there's there, but the fact that it's there at all is really exciting, especially because when we look at places like those underground lakes that are in the high altitudes here on Earth, we often find that there's life, whether it's microbial or whether there's, more macroscopic life like fish and stuff like that. We find it in all of these unexpected places, so maybe it could be there on Mars as well.
Okay, well, of course, I also have to ask you this question, though it may be rather embarrassing for an astronomer. Years ago, there was some commotion about a face on Mars. And if you look at one of the pictures taken from our Mars orbiter, it really does look like a face, a rock with the features of a human face on Mars. And there's even a Hollywood movie that ends as astronauts survey this and see this as a spaceport. But you're an astronomer. What are your thoughts? What happened when we took close-up pictures of this so-called face on Mars?
Well, the thing about the face on Mars is that there's more than one picture of that rock formation, right? And so whether you see a face or not really depends on the lighting. Sadly, I don't think that it's a spaceport or a face on Mars. But, one of the cool things about it is that it's kind of like why when you look at like a fire hydrant or like a hook on the back of a door or something, human beings have evolved to see faces in all kinds of places because it serves this fundamental function of helping us identify whether there's another person around, whether there might be a predator or danger. I really think that it's a wonderful example of the way that our brains are very much still, like the brains of cave people. We just, use these same like cave people brains now to look at images of space. So it's kind of a wonderful confluence of the way that the human mind has evolved to work and also the way that we've built technology that allows us to look at pictures of other planets.
Well, some people say that when we look at the potential colonization of Mars, the key buzzword is self-sufficiency. And I'll ask you about that after the commercial break. Professor Michio Kaku. Today we're talking about the planet Mars. We're entering season 2 of a National Geographic special, a docudrama about the planet Mars. On one hand, it has professional actors and actresses portraying astronauts as they land on Mars and then begin to colonize that planet. And then they also have scientists who appear in that program. Lucienne and myself both appear in the Mars docudrama. And once again, Lucianne Walkowitz, our guest today. Well, many people think that the key buzzword for going to Mars is self-sufficiency. That is, having a colony that is self-sufficient, grows its own food, melts its own water for drinking purposes and creating rocket fuel. So, Lucianne, first of all, did you see the movie The Martian, starring Matt Damon, where here was a poor astronaut thrown on the deserts of Mars with no resources hardly at all? Did you see that movie?
Well, probably much to Andy Weir's great joy, I read the book and I didn't see the movie.
The book was better, huh?
I absolutely loved the book, The Martian. I thought it was really creative, and that Mark Watney character is so relatable. He's kind of, despite the fact that he's an astronaut, right, he seems like kind of every person on Mars or in some sticky situation where you're really trying to figure things out. So I really loved the book. I still have to see the movie, though.
Okay. Well, in the movie, poor Matt Damon is stranded with hardly any resources that are only would last him a few days, and he would perish on the sands of Mars. Food, water, even the simple basic necessities are wanting on Mars. But using the fact that he is an engineer and a scientist, he's able to, use his own human waste to create fertilizer to grow crops. He's able to initiate a chemical reaction to create enough life-giving chemicals so he can breathe and cultivate a small farm, and use gigantic solar panels to gain energy. And believe it or not, he makes the trip back to the planet Earth. An amazing trip. Well, what are your thoughts, given the fact that the astronauts are not like the pioneers who had access to food and water and air when they colonized the United States, given the fact that Mars has no trees, has no agriculture, has no liquid water? What are your thoughts about the challenges facing astronauts as they try to become self-sustaining on the red planet?
Well, I think for any kind of near-term Mars exploration, people would be very dependent on Earth still. I think that the goal ultimately would be self-sufficiency, particularly if you wanted to have people living there for a long period of time, just because, as we discussed earlier, it takes a long time to go to Mars, and that's true whether you're a human or whether you're a cargo ship that just has, the resupplies. And the history of Mars exploration also tells us that not every mission to Mars succeeds. We've had plenty of spacecraft that have been lost or that have failed. And so you really don't want to take chances like that with something like the food supply. So having some measure of self-sufficiency, even if you're still expecting shipments of Earth, is always something that is a really, really good idea. Now, certain things, like in The Martian, for example, that idea of using human waste to fertilize and grow your potatoes.
Okay, Lucianne, we're going to have to take another short commercial break. But after the break, we're going to talk about extrasolar planets even beyond our solar system. Welcome back to Science Fantastic with Professor Michio Kaku. And once again with us today is Dr. Lucianne Walkowitz, an astronomer at the Adler Planetarium in Chicago. So the next time you are in Chicago, why don't you drop by the Adler? It's a great show. Well, Lucianne, you're also an expert not just on Mars, but also on other planets circling other star systems. And we've had this revolution in extrasolar planets. So first of all, tell us, how many extrasolar planets have we confirmed orbiting other stars in the heavens? And how many of them appear to resemble the Earth?
Well, we are now up to, I think, around 3,000 confirmed extrasolar planets. So most of those planets have come from a mission I worked on for many years that I joined actually just about a decade ago, right out of grad school, just prior to launch, and that's NASA's Kepler mission. And Kepler thus far has confirmed around 2,300 planets with several thousand more candidates that are still being examined like detectives to figure out whether they're in fact planets, or whether they might be caused by something else. And, of those, we know that there are a handful of them that are in what are called the habitable zone around their star. So that's where they get enough light that they could possibly be warm enough to have liquid water on the surface, but not so much that they're too hot and not so much that they're too cold. So sometimes also called the Goldilocks zone. Now, the thing with Kepler is that it tells us how big those planets are in terms of size. So we know that there's around 30 or so that are around the size of the Earth or so. But it doesn't tell us whether they actually do have liquid water or whether they have atmospheres. So, I think that this links back to like Mars and Venus and Earth in our solar system, for example, because if you were an alien looking at our solar system and you saw these terrestrial planets, you would not necessarily know with a telescope like Kepler whether the Earth was the habitable one, right? Like Venus might look just as good, but we know now, because we live right next door, that Venus is hundreds and hundreds of degrees on the surface, not a very hospitable place at all, and certainly no liquid water. Whereas Mars is the other side. It's got a very thin atmosphere and it's very cold. But to Kepler, all of those planets look like they're potentially habitable. So the next exciting step is to be able to figure out whether those planets have atmospheres, because those atmospheres give us warmth and pressure that make it possible for liquid water to exist on the surface, and then what those atmospheres are made up of. Are they all carbon dioxide like Mars, or do they have that nice mix of elements and molecules that allow us to breathe like we do here on Earth?
Now, as I understand, because of Kepler and the work of other astronomers, we can take a census of the Milky Way galaxy, that on average, every single star in the galaxy has a planet going around it, and there could be billions of Earth-like or Earth-sized planets orbiting these stars. I mean, don't you find that astounding, realizing that in the night sky there are perhaps thousands of planets just within your field of vision that could be Earth-like? And,
Absolutely.
Of course, then you begin to wonder, are they looking back at us? What are your thoughts?
Absolutely. One of the things that is so amazing about Kepler, all those numbers that I just gave you of, several thousand planets, et cetera, those all come from a patch of the sky, a census that was done in a patch of the sky that's about the size of your palm held up at arm's length. So the next time you're out at night, go out and put your hand up and just cover a little tiny patch of the sky and think about just the thousands of planets that we were able to find there. What taking that census gives us is billions of planets.
Okay, we're going to have to take another short commercial break, but after the break, we're going to continue a discussion of what's out there in the universe. Science Fantastic with Professor Michio Kaku. Our special guest today, once again, is Dr. Lucianne Walkowicz. She's an astronomer at the Adler Planetarium in Chicago. So the next time you are in the Windy City, why don't you drop by the Adler? It's a great show as we explore the universe. Well, before the commercial break, we had a discussion of extrasolar planets, thousands of which have now been cataloged by satellites and by astronomers here on the planet Earth. Many of these planets, around 1 in 20 or so, are Earth-like. And then it raises the next question. What's out there? Are there other civilizations that are comparable to ours or more advanced than ours out there? So, Lucianne, what are your thoughts, given the fact that Stephen Hawking, the noted physicist who passed away recently, warned us of advertising our existence because we don't know what their intentions may be like. But, well, you're an astronomer. What are your thoughts?
Well, first of all, I certainly hope that there are other civilizations out there. I think that there's a lot of argument, right, about this idea of the Fermi Paradox of if the entire universe or our galaxy is full of these other places that life could live, and if life gets started early and builds technology and things like spaceships, then where is everybody? But I think that as far as like searching for extraterrestrial intelligence goes, that's really been like a pretty small effort in astronomy, a very dedicated effort, but it's been considered so fringy that for a really long time, it hasn't received very much attention or funding. And so the fact that we haven't found anything yet doesn't mean that it's not out there. It just means that we've surveyed, as Jill Tarter likes to say, a glass of water compared with the volume of the Earth's oceans as far as the space that we can study goes. So, I certainly think that, I hope that there's life out there. As far as worrying whether it would have bad intentions or not, I resist psychoanalyzing ET. I think we don't really know what another intelligence would want or would be able to offer. Sure, maybe they would want our resources, but maybe also the reasons they're able to travel through space and time on long distances is because they've solved disease. Maybe they have the cure for cancer. So I think that there could be potentially wonderful benefits as well. And, I'm a scientist. If I don't know something, I want to figure it out. So even if the outcome is kind of bad, I still want to figure it out.
Okay. Well, let me tell you my thoughts on the question of the Fermi Paradox as to why don't they land on the White House lawn and advertise their existence? I mean, why are they so shy? My personal attitude is that when you walk in a forest and you meet the squirrels and the deer, do you engage in a conversation with them? Well, maybe at first you do, but eventually you get bored because the squirrels and the deer, they don't talk back to you. They have nothing to offer you. And it seems to me that if they can reach the Earth from outer space, from thousands of light years, they're perhaps thousands, millions of years ahead of us in technology. And what do we have to offer them? I mean, think about it. What do we as a civilization have to offer them? What do squirrels have to offer humans? Eventually we would lose interest and simply leave them alone. Now, that's my opinion, but what are your thoughts on this question?
Well, I wrote an essay a while ago for Scientific American called Do Dolphins Dream of Space Travel? And in that, I talk about the fact that it's possible that life in the universe in general maybe exists underwater if oceans are common. And, my background is studying how the radiation from stars affect planets. So if surfaces of planets, generally speaking, are very irradiated, then maybe a safe place to be is in oceans. And maybe the main form of intelligence out there is something more like whales. So, would whales necessarily want to go and explore space? Maybe. I mean, we human land dwellers explore our deep oceans, too. But, I think that wanting to travel across space is definitely something that you have to decide as a species that you want to do, just because it involves a lot of resources. So we don't know whether that's something that space whales might want to do. So maybe the intelligence that's out there is more like those squirrels and deer and even higher species like dolphins and whales than like us. So we don't know.
And speaking about whales, in my book, The Future of Humanity, I speculate about the fact that Mars, of course, is interesting, but Europa, Enceladus, there are a lot of moons of gas giants out there, much more than Mars-like planets, and they may have liquid water oceans underneath the ice cover, not to mention that there are rogue planets, planets without stars, and they would have moons, and you don't need a sun to generate energy to create life under the ocean. So one possibility is that life throughout the universe is mainly aquatic, and that we are the exception, but the chances of Enceladus, Europa, and the moons of gas giants having liquid oceans is incredibly high compared to planets like the Earth, which is in the Goldilocks zone. So what are your thoughts? You think that perhaps throughout the universe, aquatic life could outnumber ordinary terrestrial life forms like us?
I think that's absolutely a possibility. There's a lot of great things about being in an ocean. That's why life here got started in an ocean, right? It protects you. It means you have, other food sources sort of floating around you. And as you point out, it means that you don't necessarily need the warmth of a sun. In a place like Europa, Jupiter's gravity needs it and provides that extra warmth from what we call tidal heating. And so, maybe our assumptions are wrong.
Unfortunately, we have run out of time in Science Fantastic. But Lucienne, thank you so much. Thank you so much for being on Science Fantastic.
Oh, thank you. Absolutely my pleasure.
Okay, well, that's it for Science Fantastic.